Welcome to an example in which we're talking about time at the Grover Hot Springs. So the amount of time people spend at the Grover Hot Springs is normally distributed. So there's our key word, normally distributed. The mean 76 minutes, standard deviation 17, meaning the average time people spend there is 76 minutes, but there's some deviation. The average deviation from that is 17 minutes. Okay, blah, 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 blah. All right, first off, what's the distribution? See, the N there stands for normal. And they want us to put 76. So they want you to just simply put the mean and the standard deviation. So that's easy. Okay, next. Find the probability that a randomly selected person at the hot springs stays longer than 97 minutes. Okay. So what does it do? Well, I'm going to go to the notes with you in a minute, but the notes basically say draw a bell curve. That's what a normal curve is, a bell. Put the mean in the middle. 76, that's the mean, that's the average. And then put the other number, 97 minutes. Now, is that to the right or the left? Well, this is a number line. There's 76 and 77 and 78, and to the left, a smaller number, 75, 74. So 97 is going to be somewhere way over here to the right, huh? Okay. And over here, I didn't do it too well. Let me do a better, better job of this. Okay. 97 right there. Okay. Now, which way am I going to shade? Shade whatever it says. What does it say? Longer than 97. So that's going to be to the right. Do you see that? Why? Because longer is to the right. Bigger numbers. Oops, I spelled longer. I guess there's a kind of an N in there. Longer. Longer is to the right. Right? Because remember, the numbers get bigger, like 98, 99. People stay longer than 97 minutes. So if you grab somebody random, what's the chance they're going to say longer than 97? That means to the right of 97, not the left. Okay, so what does that mean? How far does it go? Well, I'll show you the notes in a minute, but this is going to be the low number right here. And this is going to be the high number, and it's going to be 4 nines. Like they're going to stay like 9999, like forever, because it's forever to the right. That's basically infinity. I know it's like, well, nobody's going to stay 9999. I'll close it down, right? I know. But the bell curve is a mathematical thing, so we have to sometimes go a little beyond reality. So whenever the bell curve goes forever to the right, that right edge is positive infinity, which the way we calculate positive infinity is 5 nines, positive. If a bell curve ever goes left forever, that's negative 5 nines. But ours doesn't go left on this one. So there's the low, there's the high. And then we go to the calculator now, and I'll show you this in the notes and calculate. We're going to put in that low and that high and that mean and that standard, and we'll get the number. All right, let's go do it. Okay, here, this is numbers from the last problem. So, okay, so now the low again. Oh, let me show you the notes. Here's where it says it. First, draw the bell curve, right? This is the unit 2 notes. Unit 2 notes coming on down to number 5. Normally distributed. That's keyword. First, draw the normal bell curve. Put the line in the middle with the mean below it. Next, put on the graph to the right or the left. The value they mentioned, we did it to the right. Are they asking for a percentage? Yeah. Go to the online normal probability calculator. When they ask for a percentage, or probably that's what they're asking for, put in the low and the high. If the graph goes forever left, the low is negative 99. If the graph goes forever right, that's us, then the high is positive 99, right? So that's us. So here we are. I'm on the online. Again, this is if you're going to we're going to the online calculator. Here's a homepage. Click on the online calculator. Get here, go down to number 8, normal probability. Click on it, come on down. So the low was 97. The high was 5 nines, 4 or 5, it doesn't matter. It's infinity, basically. The mean was 76. 17 was the standard. And calculate. And there it is, 0.1084. Beautiful. That was the answer on part B. Now, for part C, let's go back. So there's our answer right here. 0.184 for part B. Now for part C. The Park Service is considering offering a discount for the 4% of the patrons who spend the least time. They want to get people out of there at the hot springs. A little discount if you're only there you're the bottom 4%. What is the longest amount of time the patron can spend? Hot springs still receive the discount. In other words, what is the bottom 4%? Well, let's draw ourselves a curve again. So we're going to do the bell curve thing again. This is for part C now. So there's the bell curve. Again, the middle is the mean. It's the average time people spend at the hot spring. The average person spends 76 minutes. Okay. Now, they said 4% who spend the least. Well, that's going to mean like bottom 0.04, right? Watch out there. 4%, change it to a decimal. It's always 2 places back. It's 0.04, not 0.4. Okay, this side is the low, which goes left forever. So that must be negative 5/9. This side is the high, which we don't know. Do you see how I'm coming up with that? This is the bell curve representing all the people who come to the hot springs. The average person, 76 minutes. Some stay longer, but it goes down pretty quick. Not that many do. Some say less. It goes down pretty quick. Not that many do. I want the bottom 4%. Because that's the discount, the people that just spend the bottom 4% of people. So for this section, which is 4% of the curve, the low is negative forever left, negative infinity, basically, right? This is a number line. To the left are negative numbers, right? Just think about a normal number line. Right? You remember number lines from earlier in school? So like -1, -2, etc. This is like negative infinity. And then +1, +2, positive infinity. So that's why we say, right forever is positive 9999. That's like infinity to the calculator. And left forever is negative 9999. So back in part B, our shading, they said people spend longer than 97. So that went right forever. That's positive 999 for our high. This one said bottom 4%. Well, bottom goes left forever. That's a low of negative. Now you might say, nobody's going to spend negative time. I know. But again, it's a math thing. Math is made up to represent reality. It doesn't perfectly do that. For the purpose of the calculator, we're going to put in negative, whenever a graph goes left forever, negative infinity, negative 9999. That's negative infinity to the calculator. The high, we don't know. That's what we're trying to figure out. Like, what is this mark that's the top of the 4% section? So we're going to go to the calculator and put that stuff in. All right, here we go. Okay, so to do that, let me show you the notes. When they give you a percentage, I'm still on the normal distribution. When they give you a percentage already, which they did, they told us 0.04, right? Low is negative 999, which we said. The high is blank, and P is the probability given. Okay, we don't need to do about the and. This is just one person, so we don't have to worry about that. So come back here. So what was the low again? Negative 9999. The high we leave blank. Notice the mean and standard are still the same. Get rid of the P and clear that out and put in 0.04. So I'm leaving the high blank. That's the way this calculator works. You can leave one blank. You read it up here. It says leave one blank and hit calculate. So 0.04% mean and standard. Low is negative 999. Ready? Calculate. There it is. There's the high. It's showing us this little section right here, which is the bottom 4%. Stops at 46.2. That's the high. So people that spend 46.2 minutes or less at the hot springs are in the bottom 4%. They're the quickest in and out of the hot springs. It's just too hot for them. They're in and out. People that spend 46.2 minutes or less, they're the bottom 4%. They're going to get the discount. So there's our answer for that one. Part C. We got one more part. All right. So there's 46 point, like we said, 46.2383. That's how many minutes? All right, now for the final part, part D. Find the interquartile range for the time spent at the hot springs. We got to find Q1, Q3, and then the IQR. IQR is just going to subtract Q3 and Q1. So basically, it's how do you find Q1 and Q3? Well, what does Q1 mean? Let's think about that. Whoops. Let's think about that for a second. Let me come on down, or I think I can do it right here. Just squeeze her in. So, in fact, let me get rid of this number line stuff. And then come on over here. So part D, draw another bell curve. Bell curve like crazy. Not such a good one, but anyway. The mean, again, the average person spends 76 minutes at the at the hot springs. Okay. Remember what Q1 is. It's the end of the first quarter, right? So Q1 is going to be right here. Q3 is the end of the third quarter. It's going to be right there. Meaning what? Meaning we break all this graph into 25% sections, right? So there's 0.25 here, 0.25 there, 0.25 here, and 0.25 there. That's 25%, one quarter, right? That's like a football game, basketball game. The quarters in the halftime, they break the game into 4 even quarters. Okay, so that's Q1 and Q3, which we're trying to find. Okay, so to find this Q1 section, to find this right here, so we need to say, okay, I want to know this section right here. So this must be the low of this section, which goes left forever. So it's negative 4/9. This is the high, the Q1, which is unknown. And 0.25 is the percentage. Do you see how I'm coming up with that? I'm just looking at this section first off. This bottom 25%. The people that spend the bottom 25% at the hot spring. The last part, we just found the bottom 4%. Now we're finding the bottom 25%. That's what Q1 is. That's the end of the first quarter of football game, basketball game. It's the first 25%, right? So that's going to be from here to the left forever. And whenever we go left forever, that low number is negative infinity, negative 4/9 to the calculator, right? So the left edge and the right edge, the low and the high for that section. The low is negative infinity, negative 5/9 or 4/9 or whatever. The right edge is going to leave blank because we don't know it. That's what we're trying to figure out. We don't know Q1. That's what we're trying to find. And the P, the percentage, that's 25% of the bell curve. So that's what we're going to put in the calculator. Here we go. Oh, and we'll do it slow. Okay. So again, negative 9999. The high I'm going to leave blank. The mean is standard, and the percentage this time is 0.25. Let me show you where it says this in the notes. When they give you a percentage already, that is Q1. When they give you Q1, they're giving you 25%. When they give you Q3, they're giving you 75%, right? If I said, hey guys, I'm watching a football game, it's the end of the first quarter, you know it's 25% of the way through the game. If I said, oh, I'm watching a football game, it's the end of the third quarter, well, it's 75% of the way through the game. So when they give you Q1 or Q3, they're giving you a percentage, either 0.25 for Q1 or 0.75 for Q3. So it's just like the last part. So you put in the low of negative 999, the high you leave blank, put in the probability. All right, let's do it. So low, negative infinity, high leave blank, mean standard, P is 0.25, calculate. So there it is. There's the bottom quarter, 25%. The bottom quarter of the bell curve stops at 64.5. So people that spend 64.5 minutes or less in the hot springs are in the bottom 25%. Remember, the average person spends 76 minutes. So there's that answer. Okay. Let's go back and do the last part now. Okay, and now, finally, for Q3. So Q3 is going to be all the way down. And that's going to be 75%. From Q3, left forever is 75% of the bell curve, right? Into the third quarter, you're 75% of the way through the game. So the low is still going to be the same because we're going all the way left forever. The high is now here at Q3, unknown blank. And the P now is 0.75 because it's 75% of the curve. Back to calculator again. And so again, get rid of the high. This time the P is 0.75. Standard and mean haven't changed. Low still negative 9. Calculate. There it is. See how that's 75% of the curve? That's most of the curve. So that's people that spend 87.5 minutes or less in the hot springs are, they're in the bottom 75%. They're up to the 3/4 mark. People that spend more than that are in the top 25%, is what that is saying. So there's our Q3 number, 87.5, which is Exactly, right. Here's a more specifically 87.4666, whatever. Okay, now the final step is just to subtract this. Let me show that. So we've got Q1, we got Q3, and then finally I, Q, R is just the Q3 minus Q1, just this number minus that number. Hit the buttons on your calculator and you'll get that. And so there we go.